Hello, this video is the fourth in our series about the concept of nomenclature in chemistry. Nomenclature is of course just a fancy word that means naming stuff. In this video, we're going to learn how to name and write chemical formulas for molecular compounds. In our first videos, we talked about how to name and write chemical formula for ionic compounds, and we described ionic compounds as being formed between a metal or a cation and a nonmetal or an anion. What we'll see with molecular compounds is that they are formed between two nonmetals. We should also note for molecular compounds that there are no ions and no charges. This means we need a new set of naming rules for these compounds. Throughout this video, I refer to these compounds as molecular compounds, but we should note that we can also call them covalent compounds, or molecules. Before we talk about how to name molecular compounds, let's talk about where the nonmetals reside on the periodic table. The nonmetals can be found on the right-hand side of the table from group 13 to group 18. The molecular compounds that we'll name are binary, which means that we'll only see two types of nonmetals bonded together. In general, students find naming molecular compounds a little bit more straightforward than naming ionic compounds. But before we jump into any practice problems, let's talk about some of the rules for naming molecular compounds. So first, we're going to write the names of the elements in the order that they appear in the chemical formula. Second, since there are no ions or no charges to determine the subscripts in the chemical formula, we're going to use prefixes instead. Now, some of these prefixes probably look familiar. This list covers numbers 1 through 10. There are prefixes that describe numbers greater than 10, but we don't really talk about those in terms of the molecules that we look at for our class. The last rule for naming molecular compounds is the second element in the chemical formula gets the IDE ending. This is very similar to how we name anions and ionic compounds. Okay, let's put these rules to use and practice naming some molecular compounds. So first, let's name the compound N2O4. So there are two nitrogens here. So nitrogen is going to appear first in the name, so dinitrogen. And then 4 oxygens, so I'm going to use the prefix tetra and then change the ending of oxygen to "ide." Dinitrogen tetroxide. Now there is one exception to using the prefixes, and if we name a compound like CO2, we can see that exception. So if there's only one of the first element in the formula, we actually don't use the mono prefix. So this is just carbon dioxide. However, we would apply the mono prefix to the second element in the chemical formula and in the name. So in the case of the compound P3O, this is triphosphorus monoxide. So in this case, we can see that we've applied the mono prefix to the oxide name. All right, now it's your turn. Pause the video and name this compound. Okay, so in this compound, since there's only one sulfur, we don't use the mono prefix, we just say sulfur. The prefix for 6 is hexa, and then we change the name of fluorine to fluoride. Sulfur hexafluoride. If we want to reverse this process and go from a name to a chemical formula, the same rules apply. And in this case, our job is a little bit easier because unlike ionic compounds, we don't need to worry about balancing charges in our final chemical formula. We just write the chemical formula in terms of the prefixes that appear in the name. So for example, in disulfur decafluoride, we just say S2 for disulfur and F10 for decafluoride. And that's it. We also don't simplify our chemical formula the way we would in an ionic compound. In the case of a molecular compound like carbon tetrachloride, just remember that if there's no prefix on the first element, that there's only one of those in the formula. So this is CCl4. Now it's your turn. Pause the video and write the chemical formula for this compound. Okay, in this case, disulfur is S2 and dichloride is Cl2. So S2Cl2. We don't need to worry about charges, and most importantly, we do not simplify this chemical formula. We just leave it as is. For more information, check out section 9.3 in your textbook and watch the other videos in our nomenclature series.